Hi and welcome to this video on volumes, GCSE level maths made easy. Now first of all we're going to look at the volumes of these objects, solid objects, and it's wise to learn the names. So this is a sphere, a cube, a cuboid, a cylinder, a hexagonal prism, cone, a square-based pyramid, a triangular-based pyramid, and a triangular prism. When we're working out the volume of a cube or a cuboid, we get the area of the face of the cube, or the cross-sectional area if the cross-sectional area is the same throughout the object, and we multiply that by the length. So the area of the cross-section, which is c multiplied by c, multiplied by the depth of the length, which is c in this case because it's a cube. So this would be c cubed. For a cuboid, it would be the area of the face multiplied by the length or the depth of the cuboid. Here we've got the net of the cube, and this is useful for working out surface areas. Sphere. The volume of a sphere is given by 4/3 pi r cubed. Here I've used the diameter if we're not given the radius, so r is the radius. So if we're given the diameter and we want to express volume in terms of diameter, it's then 4/3 pi. The radius again is diameter divided by 2 cubed. 4/3 pi, getting rid of the brackets, d cubed divided by 8. This becomes pi 4d cubed divided by 24 when we multiply the two fractions, and then the volume of a sphere in terms of diameter is pi d cubed divided by 6. It's a cone. The volume of a cone is given by 1/3 pi r squared multiplied by the vertical height. Now the vertical height is given by this if we have a cross section of the cube. So here's the radius and here's the vertical height. So the volume is given by 1/3 pi r squared multiplied by h, h being the vertical height. So base is pi r squared, so we want 1/3 of that. 1/3 the base area multiplied by the vertical height. If you're given this, which is the slant height here, then make a triangle, as in this cross section, and use Pythagoras to find the vertical height. So remember, this would be r squared plus h squared equals s squared. Triangular prism. The volume of a triangular prism is given by the area of this triangle, or a cross-sectional triangle, multiplied by the length of the prism. Again, another triangular prism, so we'd work out the area of this triangle and multiply it by the length or the depth here. An alternative would be to make this into a cuboid, work out the volume of the cuboid and divide that by half. Cylinder. So volume of the cylinder is the area of the circle on the top, or the cross section, which is pi r squared. So this would give us this area of the circle, and then multiply that by the height. So volume is pi r squared multiplied by h. The surface area, we've got two circles, so 2 pi r squared, and then add that to this rectangle, which is r multiplied by h. So 2 circles and a rectangle, and we add those together. An annulus, the area is given by pi r squared, with the big R being the big radius to the outside of the annulus, minus pi r squared, the small radius which is to the inside. We take the pi to the outside, And in brackets we have r squared minus little r squared. So this is our annulus, and we've got a length or a depth to it now, so this becomes a hollow cylinder, and we want the volume of this cylinder. So this would then be pi r squared h minus pi r squared h. So this would be the big R up to the outside, the little r up to the inside of the cylinder. And then when we take pi and h, factor them out of the equation, we get pi h in brackets big R squared minus r squared. Volume of a sphere in terms of d, we already did this. Volume of a cube is a cubed. Volume of a cylinder in terms of d, pi d squared h divided by 4, or pi r squared h. Volume of a rectangular prism, AB, which gives us this area of the square, and then multiplied by h gives the volume of the prism. So let's just recap about volumes. So volumes, we need the area of a face or a cross section, and then multiply that by the length or the depth. So this would be this area of this cube, area of one face, multiplied by the depth or the length. Volume of a prism, 1/3 pi r squared, where pi r squared is the area of the circle at the bottom. Pyramid, so again the surface at the bottom, if it's a triangle then that area, if it's a square then that area. 1/3 the surface area of the base multiplied by the height. And again, prism, 1/3 surface area of the base multiplied by the height. Cylinder, surface area of the base, which is a circle, pi r squared multiplied by the height. Triangular prism, surface area of the triangle multiplied by the depth or the length. Hexagonal prism, surface area of the hexagon multiplied by the depth or the length. Heart-shaped prism, surface area of the heart multiplied by the depth or the length. Some interesting formulas. Nets, we've already been through these, quite good to calculate surface area. Which solid does this net belong to? Which solid does this net belong to? Which solid does this net belong to? If we want the volume of an irregular shape, follow the same rules. Get the cross-sectional area, so that would be the area of this white shape here, like an L shape. Find the area of that and multiply that by 4, which is the depth or the length. Calculate the volume here of this irregular shape. So this volume is half AB, which is this parallelogram, multiplied by h, which is the vertical height, and the volume, multiply it by L. Work out this volume. So this would be half a sphere plus the volume of the cone. And here's a brain teaser, so stop the video and try and do this.